Dzień dobry, witam wszystkich Państwa na kolejnym webinarze, trzecim już z kolei, organizowanym wspólnie z firmą GoodWe. Dziś nie będę robił zbyt długiego wstępu. Chciałem tylko Państwa zaprosić już na kolejne szkolenia, które odbędą się w lipcu. Planujemy, aby te szkolenia były bardziej praktyczne. O szczegółach będziemy informować zapewne na początku lipca. Życzę Państwu danego webinarium. Mam nadzieję, że ta godzina będzie spędzona w miłej atmosferze i na koniec Państwo wyniesiecie dużo przydatnej wiedzy. Okay, Carlos, that's it from my side. The floor is yours.
Okay, so hi everyone. My name is Carlos Silva. I'm the country manager for Eastern Europe, which basically means I manage the sales and marketing of GoodWe products in your region. The focus of the webinars over the last 3 weeks has been on Poland. However, I do understand that there are some customers or potential clients from Hungary, so I welcome also all of you to this webinar. So our strategy for Poland and for Hungary is to partner with our local Polish distributors and Hungarian distributors because we see many benefits. And Manitou Solar is a company who I've worked with Piotr and Norbert closely over for the last 4 to 5 years. So I'm quite happy that we've been able to maintain the relationship over such a long period, which is something that you don't see in the industry nowadays very often. So the focus on this webinar is on our GoodWe CNI solutions. That's the commercial and industrial, and the PV farms, to be more general. So I'll start the webinar right now. Okay, so first I'd like to go into, I guess, the concepts behind the string inverter movement towards large-scale PV plants. So you can say that we can say it's like a string inverter versus central inverter. So typically, well, historically, when people have been designing or talking about large-scale solar farms, they've been talking in terms of the inverter technology. They usually refer to centralized inverters. So these are one big central inverter which manages a whole block of PV plants. But over the last 3 to 4 years, and I do have to give credit to our main competitor of ours, Huawei, who have been able to push the string inverter solution into PV farms. So without, I guess, the strong commitment and the motivation and the convincing of clients that's been done by Huawei over the last 3 to 4 years, I don't think the string inverter inverters would be as popular as they are today in terms of the commercial and industrial and the PV farm sector. So as you can see, as opposed to having one central inverter for one block of farms, we have many small number of string inverters, which brings about many advantages against the centralized solution. And one of the advantages at the moment is in terms of the initial investment comparison. So I won't go into detail of what this table entails. However, at the end of the day, since the costs of the string inverters have reduced rapidly over the last 5 years, the cost of a string inverter solution when compared to a central inverter solution, regardless of the size, whether it's a 3.386 megawatt solution, as you see on the screen here, or a 2.5 or a 1 megawatt solution, which is very popular at the moment for the Polish tenders. When we do the maths and we take into account the balance of system components, which includes the DC combiner boxes and the installation and the transformers and the cables associated, it seems, well, it does look very attractive for a string inverter solution. As you can see at the bottom there, the dollar per watt is much lower than a centralized solution. But again, as a designer, as an engineer, what it comes down to is the appropriateness as well of the solution, along with the cost. So a number of other advantages with string inverters, because we're dealing with a lot of smaller string inverters, so the transport and the handling is much easier and it's much simpler. So for string inverters, which could be from anywhere from 20 kilograms to 100 kilograms, it doesn't take much heavy machinery to install the inverter. So on the left, as you can see the number of smaller inverters which are installed next to each other on a custom built rack. So there's no need for concrete padding or special mounting for the string inverters. You can simply just install them on the back of the PV array. And by simply installing on the back of the PV array, it brings about more advantages in terms of the protection. So you can install the string inverters in a way such they sit underneath the PV panels to provide a little bit of protection against direct sunlight, snow, rain, and hail, and so what have you, in terms of the environmental elements. So as you can see on the right, usually with central inverters, you need heavy lifting equipment, you need some cranes, you need to do a lot of groundwork and trenching and digging before you actually install the inverter itself. With string inverters, also you don't need to install the DC combiner box, because essentially the string inverters contain many MPPTs, and as I'll take you through the slides, you'll see how many MPPTs the GoodWe inverters have. So by having multiple or a large number of MPPTs, it negates the requirement of having a DC combiner box, which is necessary for when you're installing a centralized inverter. So DC combiner boxes means many DC cables and of course a very large DC cable which is connected from the DC combiner box to the inverter itself. So typically the DC cables are much more expensive than the AC cable, so it leads to a higher BOS cost. And the centralized inverters, because of the way they can weigh up anything up to 6.5 tons. Also, the maintenance cost is also reduced by not having to install DC combiner boxes and specialized monitoring inside these DC combiner boxes. We're actually using the MPPT capabilities of the string inverters to detect abnormalities within the performance of each string. DC combiner boxes also, they come with perhaps three years warranty, whereas the inverter itself comes with a 5-year standard warranty, which can be extendable to 10 years or 15 or 20 years. By virtue of the fact that we have multiple MPPTs, we don't need to install string fusing, which also reduces the BOS costs and also the maintenance costs. With typically in combiner boxes, we need to install the fusing, and they also need to be maintained. So with the string inverter solution, from the array to the inverter itself, it's a very simple DC connection. It's kind of like a peer-to-peer connection where you have the PV arrays interfacing directly with the MPPTs without any intermediate component. Whereas as you can see in the centralized inverter solution, you have your PV array connected to a string, to a DC combiner box, which is then connected to the inverter and then connected to the on-site transformer. So with the string inverters, well, grid connect inverters in general are traditionally known as maintenance free or very maintenance light products. They're IP rated at 65, so you are able to install the inverters outside or inside. As you can see in the photo, they're installed underneath the PV array. The inverters also have IP68 smart fans, which operate with respect to the outdoor temperature, and they have quite a low self-consumption. With a centralized inverter, the technology itself, it's not rated as IP65, but it needs to be installed in some kind of control cabinet, or usually now manufacturers are supplying containerized solutions where all the components of the inverter are now installed within a 20-foot or 40-foot container. There is a higher degree of maintenance associated with a large centralized inverter, and not only the maintenance, but also there is a higher degree of knowledge or expertise that is needed to maintain the centralized solution over time. Another advantage is in the case of replacements or needing to add or reduce the number of inverters on site, a string inverter, as you can see, is much easier to replace. It can take up to maybe 20 minutes to be swapped by two people, simply just disconnecting the DC outputs and the AC output of the inverter and replacing it with a new one, and the commissioning is quite quick. Typically, you don't need professional maintenance staff, or you don't need a large crew to replace the inverters. So by having multiple inverters installed on a large commercial installation, by reducing by replacing one inverter, you have a small effect on the output of the PV plant. Whereas when you're maintaining or having to replace a large centralized inverter, the inverter is offline, or the part of the PV array that's connected to the inverter will be offline for a number of hours, maybe up to days, until the large new centralized inverter is either replaced or repaired. And because a large part of the array is connected to one centralized inverter, the downtime of the whole PV plant is reduced drastically when compared to a string inverter design. So when we're looking at a string inverter solution, we have more yield, less investment in terms of the cost. We have a much more simple O&M, and the reliability and the quality is still there. So in terms of GoodWe and what we offer for the commercial and industrial market, we have the SMT inverter, which you can see is from 25 to 36 kilowatts with 3 MPPTs. Towards the end of the year, early of next year, we'll be introducing 5, 6 MPPT versions of the SMT inverter from 50 to 60 kilowatts. Right now, what we have also, we have our MT range, which is the current, or which is the go-to inverter for large commercial inverters right at PV plants at this very point in time. In this range, we have 50, 60, 80 kilowatts. We do have a high voltage MT inverter. High voltage, I mean by the output being 480 to 580 volts in the 70 and 80 kilowatt range. And this inverter needs a step-up transformer to connect to the high voltage or the distribution network. We also have bifacial compatible versions of the MT from 50, 60, and 80 kilowatt range. And quite recently, we introduced our new HT inverter, which is from 100 and 120 and 136 kilowatts. And 156 is currently in development, but we are not sure if we're going to continue on that size at the moment. But as you can see, the number of MPPTs have increased quite dramatically from a 25 kilowatt inverter to up to 136. So the MT series inverter, which I mentioned is available in 50, 60, and 80 kilowatts, has been to date as our most popular inverter for commercial PV plants and industrial and large scale PV farms, for anywhere from 50 kilowatts to 20 megawatts. So its low voltage output is specifically designed for commercial and industrial applications. So that meaning no external step-up transformer is required. It comes with 4 MPPTs, with type 2 surge protection as and string fusing is also equipped as a standard for Europe. By virtue of the fans that we use on the side, the inverter has a full load operation of up to 50 degrees, which is significantly higher than inverters that are designed with no active cooling. The HT series, which I mentioned, is a brand new inverter solution that we've just recently announced to the market. It is, or the 100 and 120 kilowatt version is a low voltage inverter, which has an output of 380 volts, which can be connected to the low voltage distribution. So this is very appropriate or a nice solution for commercial rooftops and small PV farms. The 136 kilowatt version is the high voltage version, which can be connected to high voltage networks or to a step-up transformer, which can accept a 400, 500, and 540 volt AC input. So this inverter has been specially designed for ground-mounted and utility scale PV farms. So this unit, we believe, is the one that will be quite attractive for Poland in terms of the 1 megawatt tender auctions that we are seeing at the moment. Both all three inverters in terms of the protection come with a type 2 surge protection. A type 1 surge protection is also available as an option, but it cannot be retrofitted, so it must be ordered direct from the factory. We have increased the protection rating on this range of inverters. So the MT, as you saw, was IP65, and the HT is an IP66 inverter. We have also humidity detection as a standard, and as an option, we do offer the possibility of having an arc fault protection, an AC over temperature detector on the AC output terminal, and we also have PID protection as well. So that's potential induced degradation on the panels. In terms of the flexibility, I'm sorry, there is a mistake on this slide. It should be 10 to 12 MPPTs, and the maximum DC input voltage is 1100 volts. So in terms of more yield, what we mean by this is that we are able to oversize our inverters for the commercial and the utility solutions by up to 50%. So if you look on the left, that's an example of a PV array that was installed. And we did colleagues in China did an analysis, and by simply adding 1 or 2 extra inverters, we were able to, by simply adding an extra megawatt or I think half a megawatt of PV panels, we were able to just keep the same number of inverters, whereas with other competitors, we had to increase the number of inverters that were required to be installed. So from a BOS component, the less number of inverters that you can install, the less your system costs. So in terms of having many MPPTs, so for the HT series, we have 10 to 12 MPPTs. So that can significantly reduce the influence of weak modules or mismatches that occur within the panels themselves. So with panels out in the field that suffer with hotspots, or they're broken, or there is some shading that's caused by inter-row spacing. If there are panels which are more dirty than other panels in the same string, or if different panels are at different tilts or azimuths, having a larger number of MPPTs, you're able to, I guess, share the different characteristics of one PV array across a number of different MPPTs to reduce the influence of the weaker performing panels. So as you can see, when we're comparing a large centralized solution, as you can see on the bottom, with only 1 MPPT, and comparing that to an inverter with multiple maximum power point trackers, the effects of shadow on a string inverter solution is much less than the effect of a shadow on a centralized solution. Because of the 1 MPPT, a shadow on one string of inverter will affect the performance of the entire array and will bring down the performance to the lowest performing string. Whereas in a string solution, each MPPT is working individually independently of each other. Therefore, if one string has a broken panel, or if one string is has some shadow which is caused by a building or by some kind of object, then that panel does not bring down the performance of or that string does not bring down the performance of the rest of the other strings. Also, another advantage of having many MPPTs is that as the technology of solar panels, as they improve in terms of higher efficiencies or longer higher voltages or higher currents, having multiple MPPTs allow you to segregate or allow you to connect newer technologies into one or two MPPTs without affecting the rest of the other MPPTs which are connected to perhaps lower power panels. So as you can see here in the top screen, we have a string inverter solution which is connected to 240 watt panels. Over time, or at the end of the lifetime of the panels, or if there is some kind of large scale damage which is happening to these strings, and if the 240 watt panels are no longer available, what you can do is you can replace one or two MPPTs with the 260 watt panels, which is then connected individually and independently to the inverter, which means that the 240 watt section of the array will not bring down the performance of the entire PV array. Due to the 1100 volt DC voltage, what that means is you're actually able to install basically 2 additional panels, more than a traditional inverter with a 1000 volt DC input. Our inverters have a much lower startup voltage than most of our competitors. And what you can see is a power curve from a actual PV plant in Turkey. And we've calculated that by having an earlier startup voltage and it allows you to increase not your efficiency, but your yield by 0.3 to 0.5%. As you can see, the MT inverter has a startup voltage of around 200 volts. So as you can see, in the mornings, the inverter does start up earlier, and it's able to run a lot later into the evening. There has been a lot of talk again in regards to inverter solutions which have an active cooling solution versus an inverter which has a passive cooling. So what I mean by an active cooling, an active cooled inverter has fans, motorized fans which turn on when the ambient temperature increases. Whereas a passive cooling, these inverters rely simply on the heatsink design and the way that the inverters have been designed internally to dissipate the heat that has been generated inside the inverter. And it is interesting to note that the manufacturers that have traditionally advocated for the passive cooling design have now moved on to active cooling design. So I guess from an there is anecdotal evidence that says that passive cooling perhaps is not the correct solution, or there are doubts of passive cooling with regards to commercial and solar PV plants. So as you can see on the left, our inverter is on the left hand side here, and as you can see at I think which one now. So the red line is the GoodWe inverter, and as you can see, it starts derating from 50 degrees, whereas an inverter with passive cooling starts to derate much earlier. So we did internal in-house testing, and a number of our manufacturers actually start to derate from 20 degrees. Whereas on their data sheets, they say that they start derating from anywhere 30 to 35 degrees. So there is a 10-degree difference in what they're stating on their data sheets. So that's one of the things to look out for when selecting or choosing your inverter for your commercial installations. So in terms of the GoodWe inverter, we use an IP68 rated Japanese fan. They're located on one side of the inverter. So the idea is to draw or suck cool air from one side and blow it out onto the other side, which is a typical solution for a number of manufacturers. These fans are variable speed fans. So the inverter is smart enough to control the fan speed by virtue of the temperature that is measured in the ambient and the internal temperature as well. So at the highest temperatures, the fans will be running at its highest speed, and it will reduce its speed at lower temperatures. So this also reduces the wear and tear on the fans and reduces the risk of the fans failing over its lifetime. Our inverters are also compatible with bifacial modules, which are becoming the standard now in today's PV landscape, not only in the commercial, but also in the residential sector. And by virtue of this, inverter manufacturers have also had to increase the maximum input current of the inverters because the bifacial modules have much higher short circuit current, which means that the short circuit input current of the inverter has to be increased over time. So our new inverters that we're releasing over the last year and this year and next year will accommodate for the increase of the higher threshold of DC current, which is delivered from the PV panels. So less investment, as I mentioned, in traditional commercial systems, the need of a combiner box with perhaps integrated SPDs, type 1 or type 2 were a requirement, but with the introduction of string inverters, which are now for large-scale PV plants, we include the surge protection devices, as you can see inside the inverter itself, both on the AC and DC side, and we have a type 3 SPD on the communication board. As I mentioned before, you can also have the option of having a type 1 surge protection. However, it must be ordered directly from the factory. Also, traditionally, inverters required external PID boxes, which also added additional costs to the PV plant. However, the GoodWe MT and the HT series has an option to have the PID box included inside the inverter itself, so reducing the need for an external box. So therefore you save costs on the box itself and the installation and the associated wiring with the anti-PID boxes. We also have savings on the AC cables, so we're able to support larger cables, and also our terminals are compatible with aluminium conductors, which are much cheaper than the standard traditional copper cables that we see in the industry at the moment. Our inverters can also, at a large scale scenario, our inverters do not require the neutral cable to be connected to the transformer. Therefore, you can save your AC cable costs up to 25%. We also have the parallel connection of the inverters, rather than having, I guess, one large inverter with one large cable, AC cable at the output. We have a number of smaller string inverters with smaller AC cables connected to the transformer. The MT series can support up to 120 milli squared AC cable with an external box if required. Also, which is something that might come into the future, which is the dynamic reactive power compensation. So this will help factories, especially industrial companies who are running a lot of induction motors or inductive loads. So these companies, by having these type of loads, they lower the power factor, or they have a very poor power factor on site. And in some countries, companies are penalized for having a low power factor because it increases the kVA, the apparent power that is used on site. And by having a higher kVA that is used on site means that the utility or the grid operator has to install much larger transformers. So our inverters have the ability to support or supply reactive power into the grid so that the power factor improves and increases much closer to a unity or a power factor of 1. And so this dynamic reactive power control can work day and night, so 24 hours throughout the day. So this reduces the penalty costs of having a low power factor for the industrial customer. In terms of the power factor range, we have a minus 0.8 to a plus 0.8 leading and lagging power factor capability. So by having reactive power compensation inside the inverter itself, it eliminates the need for this industrial customer to install a dedicated power factor correction unit, which typically or traditionally does the power factor improvement on site. So with this type of solution, you have the benefits of the PV plant not only improving your power factor, but also generating electricity from the PV panels and reducing the overall on-site consumption of the industrial customer. So in terms of operation and maintenance, we have LCDs on one side. So our inverters, or MT series, and the not so much the HT, but the MT series does come with an LCD display, which allows the installer to commission and operate and change the settings from the front of the screen itself. On the right-hand side, we do have inverters with a no LCD option, which simply has LEDs, a series of LEDs on the front screen, and these inverters need our SolarGo app to be configured, and typically we configure them by Wi-Fi, and in the future we'll be introducing a Bluetooth solution which will allow the SolarGo app to be connected directly to the inverter for commissioning. The inverters are designed in a way that allows the components to be easily replaced should they become damaged. So if a communication board, or if the main board was damaged by a surge, by a lightning strike, it's quite easy to simply take off the cover and replace the required PCB board with the new, the damaged PCB board with the new one. It's also quite easy to remove and replace the fans which are located on the sides, and the vents, especially as well. The input terminals are also able to be replaced, and the AC output terminals also be able to replace. So in terms of the maintenance, it's not so difficult to carry out. In terms of our monitoring solutions that we offer, we have the standard or the traditional RS485 monitoring solution, which means that all the inverters on site are daisy chained with a communication with each other. One of the main advantages of having RS485 is that you can have distances of up to 1,000 meters. So you can cover quite a whole large PV array with an RS485 communication cable. With our EasyLogger Pro that we have, you can connect up to 60 units of inverters, regardless of the size. It can be a 1 kilowatt inverter or a 120 kilowatt inverter. And we also have the SEC 1000 and SCB 1000 all-in-one monitoring solution, which I think I do touch on later in the webinar. Also, in addition, we offer a PLC monitoring solutions, which stands for power line communication. So rather than having a dedicated RS485 communication cable, which is daisy chaining the inverters, we're able to, in the PLC solution, we're able to transfer the data from the inverter via the AC cable that is connected from the inverter to the distribution transformer or the step-up transformer. So the advantages of this is that you don't have to install the RS485 cable, so you save on installation costs and you save on cable costs. However, one of the disadvantages is that this PLC is usually mostly suitable for large-scale PV plants. So this PLC solution doesn't typically work well with commercial installations or industrial customers because of the number of loads that they have. So the PLC communication, regardless of if it's a GoodWe solution or a Huawei solution or so on, these solutions typically are for large-scale PV plants which have very, very small and very light loads on site. You're able to extend the communication using an optical fiber ring. So if you have a number of PV plants in different sites, which are quite close to each other, or if you have more than 40 or more than 60 inverters on site, you can use multiple GoodWe monitoring solutions such as the EasyLogger Pro or the SCB and connect them together with an optical fiber cable, so that you have a large PV plant communicating with each other. So as I go through the monitoring solutions that are offered, we have the standard EasyLogger Pro, which is very typically used for customers who just want to monitor their PV plant and they have less than 60 inverters on site. As we go here onto the SEC 1000, so this is a nice CNI solution for customers that still wish to use the RS485, but also wish to have an export limit function. So inside the SEC 1000, we have the necessary components to realize an export or export control solution. So inside we have basically an EasyLogger Pro, and we have a GoodWe smart meter inside, which is measuring the import and the export of the grid. And this information is then sent to the EasyLogger Pro, which then controls the inverter and basically tells the inverter to either increase or decrease its active power output to maintain the export limit at the point of connection. The SECB 1000 is very similar to the SEC 1000. However, it has the option to have the optical fiber capability for the solar PV farms, which have more than 40 to 60 inverters on site. The SEB 2000 is the PLC solution with the optical fiber capability, and the SEB 3000, which is also the PLC and the optical fiber solution, but will be compatible with the HT series. So when we're looking outside of our own in-house monitoring products, we do have third-party solutions which are available. So our inverters are compatible with, for example, the media control blue logs or other media control data loggers. We're also compatible with the solar log data logger as well. So these data loggers are directly connected to the inverters and then sent to the third-party server, so the solar log server or the media control server. We do have SCADA compatibility with our EasyLogger Pro. So if a customer would like to incorporate or the PV plant into an already existing SCADA system that they have on site, we can do this via the EasyLogger Pro. So essentially there is a data controller which is the interface using a standard IEC 104 protocol, which connects to each of the EasyLogger Pros and then converts and makes the data compatible for the SCADA system. We also have a weather station solution. So a third-party weather station can be connected to the EasyLogger Pro. At the moment, we have one company that is compatible with ours, but if there are other requirements from the market, we can also make them compatible with the EasyLogger Pro. So essentially, environmental factors such as wind speed and direction, the sunlight, the air temperature, the solar panel, the cell temperature can all be collected by an environmental data logger and then sent to the EasyLogger Pro, and then which can be shown here on the SEMS portal, which is our online monitoring portal. Which leads me on to the SEMS portal, which stands for Smart Energy Management System, which is our GoodWe internal monitoring platform, which takes all the inverter information and displays them onto the SEMS portal. This allows you to monitor your PV plan in terms of the performance and any faults that may occur. And it is also useful for monitoring a fleet of PV plants. So if a customer or a developer is developing many PV plants and an O&M company has many PV plants under their control, they're able to view the performance of each of their PV plants under the one platform. We also, in the SEMS platform, we have a dashboard option, which allows you to have a nice graphical overview of the PV plants that you have under development or in construction or in operation. This dashboard is also useful for companies or businesses who would like to install a display system in the lobby or the foyer of their business. And you can use this dashboard to show the performance of the PV plant itself. In terms of the data, we use an AES 125 encryption algorithm, which ensures that the data is highly encrypted from the inverter onto the SEMS portal. Our SEMS or our European servers all fully comply with the GDPR or GDPR European regulation. The European servers are located in Europe, therefore the information does not get, although it can be accessed by China, it does not get sent, I believe, to other servers in the world. So the monitoring platform is accessible by anyone. It can be accessible by the distributor, the installer, the owner of the PV plant, and also visitors. So owners can allow visitors to see the performance of the PV plant. So from the SEMS portal, you're able to generate a number of reports. You're able to analyze the performance of your PV plants on a one-to-one or an apples-on-apples comparison. And then you can also download the historical data for the PV plants in daily or an hourly, monthly, or annual frequencies. This already showed we're compatible with third parties, and at the moment we're integrating the SunSpec protocol, which is a widely known protocol specifically in the use for inverter communication between data loggers and inverters. And we also have, as I mentioned before, compatibility with SolarLog and media control. Going one step further, we do also have the option for an API type communication. So if a customer has their own third-party server, or if they would like to develop their own web-based monitoring platform, they can do that by using our GoodWe API interface, which essentially retrieves the data from the SEMS portal and then is able to be shown on a third-party web interface. So as I mentioned, we do have our SCB or SEC 1000s do have the option or the capability to connect into a power plant controller, which is sometimes necessary. Sometimes in the grid connection, it stipulates that the PV plant must have a power plant controller, which allows the grid company to control the output or control some certain settings of the PV plant itself, and also allows the grid company to communicate and extract data from the PV plant. And this can also be done by the RS485 by the Modbus RTU protocol. As I mentioned before, the SEMS is a very comprehensive monitoring platform, which can also monitor not only the performance, but can also provide information regarding any of alarms that may be happening at that point in time. It allows you to, in this respect, it can allow you to operate and maintain the PV plant quite efficiently. So you'll receive a number of alerts via email or via the portal itself, so that you can action and repair the faults that are happening. So this allows a remote diagnosis of the PV plant, and also we have the ability to have a remote shutdown. So this remote shutdown is quite important, or is becoming important in Europe, which allows a third party such as a grid operator to shut the PV plant down or shut certain sections of the PV array down under a variety of reasons. With the MT inverter solution that we have optional mounting solutions, so you can traditionally mount it vertically. However, by the design and the fans, you can mount that horizontally if required. So we have an option from fire hazard. So for example, on the AC side, we have an installer or a customer can order the inverter with an AC temperature at the AC output terminal, which measures the internal terminal temperature of the AC connector. And if the temperature of that terminal increases due to a short circuit because the cables aren't connected correctly, then the inverter will shut down if that internal temperature goes above a certain degrees. Again, another optional feature is an arc failure. So if there is any problems within the DC cables or the DC connectors or the panel itself, then the inverter can shut itself down when it senses or when it detects an arc fault on the DC side. So in our inverters, we've moved away from using a traditional electrolytic capacitor to a thin film capacitor, which runs at a much lower temperature and lasts 4 times longer than the typical or the standard electrolytic capacitor. And it has a much higher tolerance to higher ambient temperatures. So typically this inverter will run be able to, well, the capacitor itself and the inverter will have a longer lifetime. We were the first inverter manufacturer to have the new VDE-AR-N 4110 certificate, which was released by TÜV Rheinland. So this is this is a German certificate, which is very difficult to get to. Essentially, it is a certificate that you need to connect the inverters to the medium voltage and the high voltage network in Germany, and a number of countries in Europe also refer or also require inverters to have this VDE certificate to allow connection into the grid. So this is a very robust, the inverters go through a very robust and intense testing and process, and which usually takes up to 2 to 3 months. And the cost of having a certification like this is anywhere between 15,000 to 30,000 euros. So as you can see, there's quite a large commitment that's been made by GoodWe to have our inverters certified for this particular standard. we have, in terms of the design of the inverter internally, we have redundant components such as master-slave DSPs. So, for example, if there is a problem with a master chip, the slave chip can take over the functions of the master until the master has been able to reboot itself and then come back online. And we also have multiple AC relays on the output to allow a much higher level of protection in terms of anti-islanding. So in-house, before we ship the inverter, we subject our inverters to a number of quality tests. So we test them for the IP rating. We take them through a high and low temperature tests. We do some EMC testing, and what's really new at the moment, we do a vibration test. So we put them in a chamber, and it's connected to a machine, which essentially shakes the inverter and is supposed to simulate the transport of the inverter from China to a warehouse in Europe. So just ensuring that components are securely tied and fastened to the PCB boards and the body itself. We go through a number of other aging and ATS tests on the inverter. So as you can see here, on the right-hand side, this is the aging or the ATS test that we put our inverters through, and this room is run at a particular temperature. I think it's 40 to 50 degrees, and it's at a high humidity. So we run the inverters at its 100% output, and we go through a number of tests through this type. Our production line is certified for ISO 9001. So we have a number of strict quality and control procedures and processes in place to ensure that the inverters are manufactured to the specification that we require. Our plan is anti-static. So that means when you go through or enter the factory, you go through a anti-static process or test, which takes any of the electrostatic charge that you have accumulated within your own body and discharges it before you enter the factory. And every employee that enters into this building has to go through this this anti-static entry point. So I'll just take you through some reference cases, just to show you that that we have deployed, or our customers are using the MT and the series inverters on large PV solutions. So we've installed in China 750 kilowatts. These are industrial customers, 800 kilowatts. 2 megawatt solution in Shanghai using our MT series inverters. 5 megawatts, 25 megawatts. So there was a large installation in China at 42.8 megawatts. In South Korea, there's a 2 megawatt power plant that was installed for an LG, under an LG project, 5 megawatts. In Bosch in India, our inverters are being used quite extensively in India due to its reliable operation in high temperatures. 6 megawatts. Coming closer to Europe, a number of our inverters have been deployed in Holland or Netherlands, 10 megawatts here and there. 6 megawatts in Turkey. And that's it. That's it for the webinar today. So thank you for your time. If you have any questions, please don't hesitate to write it in the chat. If it's in Polish or Hungary, you can still, I guess, enter it in there, and then either Piotr or someone from the Manitou Hungary team can translate. But thank you for your time, and hope to visit most of you over the next coming months. Piotr, would you like to say some parting words, or David? So if there are no questions, I'll close the webinar now, and I wish you a great start to the week. Thank you very much, everyone, for joining in.